All right, so first to get the effective resistance, we need to get the effective resistance of the parallel branch. We'll add that to the 8 ohm resistors, and we'll add that resistance to the effective resistance of this parallel branch over here. So using the parallel rule, I just did 1 over a resistor plus 1 over a resistor and took the inverse, and I get 11.52 as the value for this combo, right? Or excuse me, this parallel branch right here has an equivalent resistance of 11.52. And then it's next to, in a single wire, to an 8 ohm resistor. And that is next to what is essentially the same thing as the first one here, right? So that also would have an effective resistance of 11.52. But to get the total, we need to add these up because now they're acting like a 11.52 resistor next to an 8, next to another 11.52. And so we just need to add these up. So essentially, it's behaving like 3 resistors in series with those values. And the rule for series is you add them up to get the effective resistance. So essentially, this whole circuit here has 5 different resistors. It actually behaves like one resistor with the value of 31.04 ohms to it. Now that we have the total voltage and the total effective resistance, we could go ahead and do I equals V over R and get our total current of 3.22 amps. All right, so now we are looking to get all those individual values. The voltage across the parallel branch, the resistor, and the second parallel branch, and the current through every single resistor. All right, so this is the circuit we began with. And when we started to simplify it, we said, well, the parallel branches behave like a resistor with 11.52 ohms. And so we could use that to figure out what the voltage is across that branch. Remember, the voltage is the same across both the 18 and 32 ohm resistor. So as it behaves as it's a single resistor of 11.52, and we know from before it has a current of 3.22 going through it, we can figure out the voltages. So for the first one, we'll do IR, 3.22 times the effective resistance, 11.52. The third R, we'll do 8 times 3.22. And then the third one will be the same as the first one. So utilizing that strategy, we see the respective voltages. And notice that they add up to be the total 100 that is being provided to the system. Okay, so I just blew up one of the parallel branches there. Since the first one and the last one are the same, I'm just going to show you with one of them. We found that the voltage across those branches was 37.1. So that's for each resistor, right? They both have the same voltage. Well, you know they're given values for the resistance, and so we could just do V over R to get the current going through each resistor. And notice that 2.06 and